Swayam Prabha. Digital India. Educated India.
Welcome back, my dear students. So, this is the 28th lecture happening for project management, and for the 27th one, if you remember, I did discuss in the last two slides about the concept of duration, the concept that it is a weighted sum of the time based on the fact that I am taking the ratios inside the bracket. If you remember, in the 336th and the 335th slide which I mentioned, is the ratio of the present value of all the incomes which had happened divided by the price of the project, and that weights is multiplied with T1, T2, T3 correspondingly, and I sum them up. Then I also showed you that the rate of change of B, which is the price divided by B, is equal to minus D, which is the duration, into the rate of change of Y, which is the interest rate. So, that concept of how you do the calculation is not important for our course, is more of a learning experience to use the applications. So, anybody interested can definitely pick up those concepts from a good finance book. That is the point 1 which I wanted to mention. Point 2 is that you may have seen different formulas coming up for the interest rate calculations, how interest rate, IRR, net present value were all being used, and I did give you a feel that how they can be used for to find out the overall return of the project, and based on the fact whether the project is actually feasible or not. Now, our main concern for this trying to discuss these concepts are that they should be in tandem with the concept of project management and how they can be utilized. So, rather than trying to do any direct problems, though if we do, it will be very simple in nature, it will be more interesting to see how these concepts are utilized in the project management case. So, let me continue and try to finish off the concept of the different type of financial concepts based on which a project can be evaluated. So, the next point which is there in the slide in front of me, which is the 337th one, is the return on investment, which is ROI. So, calculated technically, return on investment means basically the some sort of efficiency calculation which is given by the ratio of output by input. So, what is my output divided by total quantum of input would give me the ratios, which is the efficiency. So, if I am calculating my return on investment based on the fact that I have only the overall quantum of investment is happening and plus and minus at any point of time, t is equal to 0, t is equal to 1, 2, 3 till the last value of t is equal to capital T, and the input output cumulatively at each point of time is given by c suffix 0, c suffix 1 till the last value, which is c suffix 10. Then the formula which is given in front of you, which is the second bullet point, is basically the return on investment. So, the numerator which is I am circling now is basically the time value of money as of now. So, all investment had taken place at different points of time. So, those points of time are T0, T1 till T capital T, and what are the investments inflow outflow which is happening at those respective points? They are C0 till C10. So, I find out the time value, and what is my overall investment happening, that I have to again calculate and find out which is happening at I0. So, this is the I0 which I have I t is equal to 0 in the suffix. So, now you may be thinking that why have I taken only one time? So, I am considering very simplistically that all my investments are happening at the bulk amount is happening at I is equal to I time T0. So, if there are any independent payments or investments which are happening, I can find out the time value of those investments also and then add up and use them in the denominator. So, I did not do that because I wanted to basically explain that in the qualitative sense. If you go to the third bullet point, which is the return on investment based on the fact what are the revenues and what are the costs, And again, if you remember, I did mention about interest rate being different for the investments and the loans. So, the investments and the loans have different interest rate. If you remember, I did mention about the concept of demand and supply. So, here the interest rates are given for the cost as R, the suffix 0, 1, 2, 3 are for the time, and comma C means for the costs. Similarly, if the suffix is R in place of C, they are the revenues. So, the first term is minus C 0 divided by 1 plus R 0 comma C to the power 0. This is the cost as of now, time t is equal to 0. Similarly, minus C 1 divided by 1 plus R 1 comma C to the power 1 is for the present value of all the cost, again being calculated at time t is equal to 0, and all the negative values basically signify that. If I go to the positive terms, which is basically R 0 divided by 1 plus R 0 comma R to the power 0. Similarly, the second term is R 1 divided by 1 plus R 1 comma R to the power 1, correspondingly all these things. So, add up all those values, divide by the investment, which I again consider is happening at time t is equal to 0, which is I, t is equal to 0 suffix, and then I find out the return on investment. So, return on investment in very simple sense, if you remember, in the first part of the course when we are doing the decision problems, I did mention that you can basically rank them or find out which route to take. If you remember clearly that we were considering the problem from the right hand side, trying to find out what is the expected value, compare the expected value and take the decision where the expected value was the highest, and based on that we proceeded one step at a time till we reach the so called source where the decision was being taken, and that was done for the moped problem, that was done for the oil rig problem. Now, if you consider the concept of this return on investment, it is slightly different. In those problems of the decision tree analysis, we only consider the expected value. And if you remember clearly, I did mention in the fag end of the Word document where we were solving the problems for the rig problem or the drilling problem, I did mention that in case if the expected value are the same, what you will do is that you will take the ratio of the expected value to the variance or the dispersion, rank them from the highest to the lowest and take the one which is the highest, or else you will try to find out that the ratio of the risk to return, rank them from the lowest to the highest and take the one which is the lowest. So, if you see the return on investment is exactly the same. So, that the numerator is basically the outflow and the denominator is basically the amount of inflow in the sense the amount of money which you have invested in the negative sense. So, obviously, loss I am considering as negative of profit, or profit I am considering as negative loss. So, if you are careful with the sign, the confusion would not occur. So, again what you will do is that for the return on investment you rank them from the highest to the lowest, considering the efficiency is where the output is on the numerator, input is in the denominator. You will take them in such a way that you get the highest value, and if you are trying to basically take the other way around, rank them with respect to the input to the output, you will reverse the ranking, take the one which is the lowest in the other way around, like efficiency wise, not wise. Now, why I am mentioning is that again I will just try to pause, because I thought and I think students apart from doing a course should also think laterally. So, there are different techniques of non-parametric method of ranking, and one was that which we did discuss, which was the AHP one. There is a concept of data envelopment analysis, which uses simple optimization tool or OR tools in the very simplistic sense, and that gives you excellent results. So, there we consider the ranking of different decision making units, which are the DMUs, in such a way that you find out the efficiencies based on the fact that in the numerator you have the output, in the denominator you have the input. Based on that you try to find out what is the efficiency and rank them. And in case if you are trying to reverse the the equation which is the input to the output, then you do the ranking in the reverse direction, still you get the exact results, and they are very heavily utilized in DEA, the method. This is just for the interest of the interested readers. Utilizing the time value of money is very important. Based on that fact, we can find out the return on investment. Now, this concept which I just mentioned is that the concept is exactly same in some sense to the ratio of expected value by variance or the ratio of variance to expected value. So, used in the just opposite sense. Also, we may be interested to find out and calculate using the formula of the expected value of the utility and the variance of the utility. Because in any decision, if you consider, even though practically it may not be feasible, we may be tempted to find out what is the utility, what is the net worth of a decision from a project, from a decision, from a gamble, from a certainty event, whatever it is. So, we find out the expected value of the utility, divide by the variance of the utility, rank them from the highest to the lowest, take the highest one. If you want to rank them from with respect to the variance and divided by the expected value of the utility, you rank them from the lowest to the highest, take the one which is basically the lowest. So, I will again come back to this project graph, and if you remember, we did do one of the problems in project. So, it may be a repetition, but I will strongly urge the students to go through these slides which I will be discussing, because it gives you a different picture that how the concept of variance, how the concept of expected value would be utilized to calculate the probability of trying to finish off our work within a certain time frame. So, depending on the nomenclature, we have two different ways of depicting. If you know, if you definitely have gone through the other slides, and I have been mentioning it time and again, which is the activity on arc and activity on node, which is AOA and AON concept. So, here is the node which is shown as a blue circle, and the arc is the black arrow which you have. Now, consider the PERT concept, a simple another example based on activity on node network diagram. The first column are the immediate activity which you have in front of you, which is A, B, C, D, E, F, G, H till the last one, and the descriptions are given. So, it is basically trying to build up the system where you build the internal components, modify the floor and the roof, then build up any air installation. So, you are trying to basically implement a system for air pollution and corresponding structure. So, descriptions are given in details in the second column, and the third column basically has a predecessors, which means that before C A should come, or before D B should come, and if you see the last one before H F and G should come. So, based on that we will first draw the diagram. So, node A represents activity A, node C represents activity C. So, this is the edge on arc, and the edge or arc represents the precedence relationship happening between two tasks or activities or jobs. Now, in this diagram, I have not started the problem in this diagram. So, these are the different sequences of jobs you may have. A leads to B, B to C, and B to D also, but D cannot be completed until unless B and C is finished. In the second set diagram, which is there in slide 342, it means that A leads to C and then C leads to E and F in some sequences, but it gives us no relationship between E and F. So, E and F can end at any certain point of time, provided they are being followed up after C. So, in this simple diagram, we have basically given that A and B are basically the so called starting nodes. So, this I want to point out very clearly. So, if you remember, technically it is always best to have one source and one sink, because based on that we are able to time the overall project in the best possible manner. Best possible manner means that we are able to find out the time duration of the project, time duration of the activities, time duration of the critical path, time duration of the non-critical path, in the sense that they give us the exact answer, rather than having two different nodes of starting or two different nodes of ending. So, in this problem we have two different nodes for starting. So, A leads to C and F, B leads to C and D and E, and if you follow that set of nodes and arcs which are there. C goes to E, F, then D goes to G, and after F, E and G finishes, you basically end the overall project, which is H. So, if you note the right side of the diagram, which is on 343rd slide, it means that I am trying to follow the norms as per the nomenclature, where there is only one node, which is the sink, which basically ends the task. But if I consider the left part of the diagram, which is there in this slide, which is the 343rd slide, it means that I have basically two different sources of start. The project network began on more than one node and ended with single node, other variance, which was in the 343rd. In this one, if I have a project is happening in this 344th slide, project is starting at A, but ending at two different nodes, which is E and F. So, it says that beginning with one node and ending with more than one node. And in the second diagram in 344th, which was in some way related to 343rd, we have two different nodes which is starting and two different nodes E and F, which is ending. So, hence it is written that beginning with more than one node and ending with more than one node. The start and finish boxes, so they may be repetition, but I will still request the candidates and the participants of this course to please go through what is being discussed, because we are trying to cover a lot of different concepts in a very simple way, such that it at least kick starts the concept in the candidates and they get interest and read the books. If you remember, I had given a lot of good reference books which are generally used, and if you search the market, you will get the hard copies of those books at a very cheap price, and if you search the net, I am sure you will get the soft copies in the PDF format of this book. The start and the finish boxes tie the network off at its end and give us a sense that the project has a starting point, has an ending point. So, if you remember the last diagram which we considered in the 344th slide, it had a start A, B. So, they were being combined in start and the ending of E, F basically being combined for finish. So, now node 1 represents the activity A, node 2 represents the activity A. So, now the activity is basically being converted. If you see the two diagrams, it is AOA, which is activity in arc, the other one was basically activity of node. So, whichever you do, be very careful that once you start following the concept, use that throughout the diagram. So, these are the examples of activity on arc. One leads to 2, so that is activity A in between. In the second one, it is 1 to 2 or 1 to 3 basically means A and B. Then in third diagram, 1 to 2, 1 to 3, 2 to 4, 3 to 5 are basically A, B, C, D, and between 4 and 5 it is 4, and then it can continue. So, this is another way of trying to show the diagram. So, you have basically only one source and one sink. So, now you are able to basically implement that accordingly. So, this is activity on arc. So, the activities are subsumed and being shown in the arcs, it is not under the nodes. So, note that in the problem the work begins on a single node and ended in a single node. So, when constructing the node and the AOA, AOA and AON, we should be careful. So, if you see the first diagram which I am trying to basically highlight now, it basically has two different arcs A and B going from so called the node 1 and 2, which is not marked, I am trying to mark it for your own convenience. So, this is not allowed, because here it would mean that two activities are basically have the same start and the same finish, which is not allowed. If you remember one of the earlier assumptions based on which we started the PERT and CPM. So, rather than we will try to basically bring a dummy activity in between the jobs which I am trying to basically, or the nodes I am trying to mark as A, B and 1, 2 and 3. So, it can be done accordingly. Here in this case, two different dummy activities are being considered, which is D1 and D2 in this figure, in the second set of figure. And if you compare with the first set, it means that the activities which are now I am marking with the hashed lines, they are basically starting somewhere between A and somewhere between B, which would be very confusing to implement. So, all the precedence diagram are given on the left, I will leave that to the reader or the class people or to people who are doing this class to see it and then make a comparison what I was discussing. Now, let us go consider the following table of activities which are given. So, the activities are given starting from A to H and the precedence are given in the second column. The optimistic time, if you remember the optimistic, the pessimist, then the most likely time based on which we will do the calculations is given in the third column, which is the optimistic time A, the fourth column which is the most likely time M, and the pessimistic time which is basically the B, which is the fifth column. So, now I need to find out the expected value and the variance. So, if you know the expected value, it is basically A plus 4M plus B divided by 6. So, this is the expected value, and if I want to find out the variance, it is B minus A by 6 whole square. So, this is the variance. So, variance and the expected value have already been calculated and they are given in front of you. So, I am not going to do the calculation, please pause, see the 351st slide and giving A column which is the third column, B column which is the fifth column, and M column which is the fourth column, do the calculations to find out the expected value and the variance. So, I have drawn this graph based on the precedence diagram, do it yourself, you will find out, but only one thing which I want to point it out is that there are two nodes starting. So, that should be avoided. So, in order to avoid that, and also keeping in mind the red line which you have in front of you, which is joining A to C, C to E, E to G and G to H is basically the critical path. You can do the calculations and find out the critical path. So, that I will leave that to the candidates. So, ACFH, ACEGH, BDGH. So, if you sum up the expected value on each path yields that through each path the time durations are given as 9, 15 and 14 weeks. With the expected value of ET is 15 for ACEGH path. So, this path is defined as the critical path as I mentioned. So, despite the beta distributions which you have of each activity, the assumption is being made that the number of activities in the critical path is high, hence we are able to use the central limit theorem. So, for which the variance we need to find out. So, how do you find out the variance? Let me repeat it, you add up the variances or all the paths which are there on the critical path, and that is sum is the variance. If I want to find out the standard deviation of the critical path, add up all the variance, then find out the square root. So, this I have already said few times, but I am just repeating for the benefit of the candidates. So, now I basically converted, if you remember in the 353rd slide, the activities were there on the nodes. Now, I have converted the activities on the arcs. So, now there is only one starting node which is 1. So, it is not A, it is 1. So, again if I follow the critical path is exactly the same A, C, E, G, H, exactly as similar to the diagram which I showed in the 352nd slide. So, these is basically the PERT concept based on the fact the activities are on the arcs, in that one it was activity on the nodes. So, given that the given expected value is 15 weeks, I find out the variance which I just did in the 353rd slide. So, the variance comes out to be 3.11, which is one should remember. So, before I go into the first two bullet points, let me go to the third one. One should remember that 1.76 is the square root of 3.11, that is the standard deviation of the expected completion time. So, now we have this average value is given as 15 and the project duration some deadline based on the fact by what has been mentioned by the customer, what you think is feasible, what is the actual timeline based on which you are doing your work depending on different constraints. If you think that any time excess of 16 which is problem for you, so you will try to find out that before you start the project or you have proceeded some time in the project, you want to find out that what percentage of the overall project is to be completed within that 16th week, provided that the average time to complete the work depending on the PERT concept is 15 weeks. So, again you will simply go to in the simple calculations, remembering the fact that even it is beta distribution for each activity, cumulatively when you take them using the central limit theorem, it becomes a normal distribution. This I am mentioning time and again, because this a very important concept which comes in project management, and it comes in every sphere of life in different type of calculations. So, I want to find out that what percentage of the job is to be finished, if it is greater than time period is greater than 16. So, this is probability would be 1 minus probability x being less than 16. So, what I do is that I have these calculations, x minus the expected value of x divided by the standard deviation of x. So, that should be less than equal to 16, which is the duration, minus expected value of x divided by standard deviation x, which is a very known equation we have been solving. So, this gets converted into a standard normal deviate z, which is here, and this gets converted to a small z, which is the realized value which we know. So, what is the realized value? It is 16 minus 15, which is 1, divided by the standard deviation. So, what is the standard deviation? If you remember, it is 1.76, which is the square root of 3.11. So, that value you can find out of depending. So, it is 1 minus 0.716. So, it will be, I am giving a very rough value, it will be something less than 30%. So, about 28 point some value of the work is still pending in case the work project has exceeded the 16th week. So, if I want to find out what is the cost implication, you have to go through the contract, see what is the overall cost value which is incurring. So, what is that 28% which I say? I am taking a value of 28% roughly. So, you will try to find out what activities are left, what is the overall cost implication for there, are they very high value items, in the sense do those activities take a lot of time. So, obviously, it means the cost complication is very high. Added to that, you will always have the fact that if you have exceeded the duration of 16, obviously there would be penalty. So, is the penalty on a linear case, is the penalty on a non-linear case. So, all these implications will come into the picture. So, now if you remember also that if I want to find out, I am again repeating a small set of problem which we have done earlier in one of the lectures. So, consider that I want to find out that what is the probability, or what is the portion of the work which is possible to do in a time frame of, say for example, 16 to 18th week. So, what I will try to find out is that the probability that x, which is the time duration, is greater than 16, but less than 18. So, we will do the calculations accordingly. So, if I go to the normal distribution, even though I have not shown that, I am trying to show it here. So, this is the 15 value average, this is 16, this is 18. I need to find out what is the overall area inside this graph. So, this you can do using easier integration, but for this our case standard normal has the tables, we do it. So, again convert this 16 into the standard normal, 18 into standard normal, you can find out the probability. So, the assumption is that the summing up of a sufficient number of activities follow a beta distribution yields a result which approximates or approaches the variable which is normally distributed, and as x t is given normally distributed with some mean and some standard deviation or variance. So, this is again being reiterated for the benefit of the candidates who are doing this class. Thank you very much and have a nice day.